All right, a short pre-lab lecture on the delta H of vaporization or heat of vaporization for water. This is a kind of a funny looking setup with two condensers. The first thing you want to do when you arrive, and I'm assuming that you've read the manual and know what the experiment is about, the first thing you want to do when you arrive is to turn on the water so that we have water going through the condensers. And your tap water should be connected to this one and come in the bottom of this one. It's going to go out the top, and then it's going to come back down and feed into this condenser and go up this condenser and come out the top, and then that one will drain into the sink. So it looks like it attaches to the tap, but that's just a weight to make sure that that drain hose stays in the sink. The other water tap that you're going to turn on and turn on to maximum, in this case, is the one that's attached to the vacuum. So the water tap that's attached to this hose should go on full blast so that I'm actually generating a vacuum in my system, or a low pressure. Running water doesn't really generate a good vacuum. So if I back up here, you'll see that there are two sensors on this contraption. The first one is a temperature sensor, so right here. And the second one is a pressure sensor, which is right up here. And the pressure sensor senses the pressure right here in this line, which is going to reflect the pressure inside our system. Okay, so once your water is running through your condensers, don't turn the heat on yet on your heating element. Keep that off, but go back to your pressure sensor here. And this is a little dial that you can open it up completely or close it completely. Please open it up completely so that this is open to the atmosphere. And you will read a pressure on the computer, which is facing the other way, but we'll turn that around for you. It's attached to Logger Pro software, so record the pressure in kilopascals. So since it's open to the atmosphere, it should be about 101 kilopascals. Okay, just to make sure that everything is working. And the temperature reading, which will also be displayed using Logger Pro live feed to your computer, should be about room temperature because we haven't actually turned the heat on this yet. So that's your starting point. Now we'll go back and generate the lowest pressure that we can. So turn this dial so that it is closed completely. Okay, when you close this completely, it's closed to the atmosphere. That's going to generate a low pressure in here, and it's going to fall and fall and fall your pressure reading until about 15 kilopascals. I'm guessing it could be 17, it could be 12, but somewhere in that range where it's steady. And again, the pressure and temperature are being displayed on the computer. None of that data is being saved, so you just use it as a display. When it arrives at a constant value and you want to copy it down, that goes into your lab book. Okay, so when the pressure is steady, copy it down. Now let's see at what temperature water boils at that pressure. And so at that point we'll actually turn on our dial here, our heater, and begin to heat the water. At a low pressure, the water should boil at a low temperature, so you don't need a whole lot of heat. Ask the TA and your instructor for assistance, because some of this water will be, it's hard to tell sometimes whether the water is boiling, bubbles due to degassing, or bumping, because of course it's not stirring, but there are glass beads in there to control that. And I'll tell you, the frustrating points are the early ones, because it is difficult in the system to boil water at a very low pressure. It's easy in principle, but it's difficult for the temperature to be steady. So don't get frustrated. The points get easier to get. Conditions are easier to achieve as we go up in pressure and therefore up in temperature. So once the temperature is now steady, you can record the boiling point of water at that pressure. So we've established the bookend pressures, let's say. The high pressure was about 101 and your low pressure is about 15. And we want 10 points on that line of pressure versus temperature for raw data. So go back to your pressure sensor now. Remember, we closed it all the way. Open it just a little bit. How much? Well, let's say you opened it too much and it went all the way up to 50 kilopascals. I'm not going to get 10 points if my second point is now at 50 and my last one's at 100. So I would turn it back and say, let's establish a pressure at around 20 kilopascals. Okay, get that steady. And now let's heat the water to see at what temperature it needs to be to boil at 20 kilopascals, and so on. So try and get about 10 points. You should be plotting your data and analyzing your data before you finish up here and go home. So you can continue to work on that computer and actually generate your raw data plot, which will be pressure versus temperature. You should get a nice curved line that looks like that portion of your phase diagram for water. Then you want to convert that data to plot the ln of pressure against 1 over temperature. Make sure your temperature is in Kelvin. And you should get a nice straight line. Look at your manual and see what value you can get out of the slope. Okay.